Vaal Lifestyle Center. The Vaal Lifestyle Center is a light warehouse and factory building located on the corner Beethoven and Imam Haroon Road, Duncanville, Vereeniging in Gauteng. The project brief. The client for the project is Palms Properties, architects are A4 Advisory and Consulting, and the primary contractor was Senjo Construction. The vision for the Vaal Lifestyle Center was to create a modern and industrial warehouse development that could accommodate a range of warehousing, showroom, light industrial, and commercial uses within a flexible and adaptable framework. The client required a facility that maximized the value of the site while providing large-span, column-free spaces capable of responding to changing tenant requirements over time. Our challenge was to move beyond the traditional industrial park model by creating a development that combined operational efficiency, construction practicality, and long-term flexibility with a strong architectural identity. Steel became the foundation of both the architectural and structural strategies. The modular portal frame system allowed us to create large, uninterrupted spaces while simultaneously shaping the architectural language of the development. The repetitive gable-form roofs establish rhythm and continuity across the site, while the exposed steel elements celebrate the industrial character of the building. Rather than hiding the structure, we used it as a design feature, where the structure becomes the aesthetics and the aesthetics become the structure. Large open-plan spaces without internal load-bearing walls allow tenants to adopt and reconfigure their units over time. The portal frame system provided the perfect answer for the long spans needed to achieve this flexibility while maintaining slender structural elements and maximizing usable floor area. Most of what the architectural team intended to develop within the project was to follow the idea of multiplicity and multivalency. Multivalency, we believe, is probably the ultimate form of sustainability in the 21st century. We've seen a series of buildings and structures that often get dilapidated, and that's specifically because buildings are designed with singular purpose. Our goal for this project was to create a building that could not only perform one function, but that could become many functions over time and could adapt to many tenant needs as years progressed and times changed. The project was completed late 2025, and the total cost of the project topped out at roughly 40 million rand. It consists of a structural steel portal frame and is cladded in a steel sheet, and the primary sector that the tenant mix caters to is factory, warehouse, and industrial. The project overview and written motivation. I'm unsure.
We're not going to go through this.
That's fine. So let's go through on. Okay, steelwork. So to fully appreciate the use of the steel in this project, I think it's quite important to understand the history of Vereeniging and the broader Vaal region. Founded in roughly 1892, Vereeniging grew rapidly because of its strategic location on the Vaal River, abundant coal reserves, and strong transport connections. Over the decades, it became one of South Africa's key centers of industry, engineering, and manufacturing. The development of companies such as ArcelorMittal South Africa and steelworks in nearby Van der Bijl Park further cemented the region's identity as the heart of South Africa's steel industry. As architects, we saw an opportunity to acknowledge this heritage. Rather than using steel purely as a structural solution, we embraced the architectural expression that reflects the history, character, and economic foundations of the Vaal Triangle. The result is a contemporary commercial development that respects its industrial roots while looking confidently towards the future. The cladding and the envelope was intended to both be a standout, but also something that fitted into the context. Duncanville, just north of the Vereeniging CBD, is home to many industrial buildings that service different functions, but also service retail to a secondary market. The cladding, therefore, needed to be something that stood out and created a unique identity, but also something that responded to the local context and blended in seamlessly with its neighboring environment. The structural framing was designed in-house by A4 Advisory and Consulting. The contractor was done by the steelwork contracting was done by the primary contractor, Senjo Construction, the steel detailer being B&T Steel Construction, and the merchant being Pro Steel. The structural steel framing made use of a hybrid structural system comprising of steel framing and precast hollow core slabs. A repetitive structural grid rationalized and simplified fabrication and accelerated erection. The primary framing was made out of I sections and laid and transferred load into the ground by means of a raft foundation. The images below indicate either erection, process images during construction, and images of people actually utilizing the building or utilizing spaces prior to completion. And some of the primary elements of the structural framing was how do we maintain thin columns, achieve good head heights to get both a ground mezzanine as well as good factory and warehouse retail head heights, all while maintaining the structural load and maintaining the minimum member size that's not over-spec'd or over-designed. The walling system made use of a precast or of a in-situ concrete wall, and that replaced a typical brickwork envelope that would have been used to stabilize the structural frame. And that the use of the precast system was actually driven both as a suggestion by the client in initial meetings, but also as a speciality that Senjo Construction usually undertakes. The walling system is something that people in the Vaal or contractors in the Vaal aren't necessarily used to, and therefore the walling system played part in economic sustainability, wherein we could teach and educate really skilled brick masons a different walling or envelope system. And this then integrated seamlessly with the steel structure, because the in-situ formwork board could have been integrated into the webbing or on the external elements of the webbing, but it was basically easier to manipulate and easy to pour because of the choice of the wall in conjunction with the choice of the portal frame. Structural framing. Structural framing. So most of what I've said previously probably covers the gist of the structural framing, but the client in this case was one who also really influenced and advocated for the use of steel. Being a client who has previously developed many properties, he's realized the benefits or the functional benefits of steel versus concrete, and it's tenfold. But I think to sum up the construction images, these images illustrate the construction journey of the steel structure, and they demonstrate how the repetitive structure simplified the erection. It improved construction efficiency, standardized structural members, allowed rapid assembly, all while maintaining dimensional accuracy and also quality control. And I think these images also highlight the scale of the steel framework and the role that it played in shaping the final architectural form of the development. Just a second. Okay. The structural framing system, like I said previously, consisted of a hybrid solution. And the approach allowed us to optimize both structural performance and construction efficiency. Primary steel member spans were up to 10 meters long, creating large column-free spaces suitable for warehousing, retail, and showroom applications. The use of repetitive structural grids simplified fabrication, accelerated erection, and reduced overall construction cost. One of the key advantages of the steel system was constructability. Because the majority of components were fabricated off-site, quality control was improved and erection time was significantly reduced. Okay, so coordination, the full service coordination was handled in-house at A4 Advisory and Consulting, wherein all consultants, architects, engineers, meaning structural, civil, mechanical, all produced digital models, which were then linked into a federated model and run for clash detection on Navisworks. What this does is it allows us to make sure that we have a clash-free building prior to getting on site. It reduces the amount of variation orders on site, and it also allows us to have extremely accurate bills of quantities and extremely accurate service coordination. So we think a key part of the service coordination within this project came digitally. And even though service coordination prior to getting on site was at 100%, there were one or two clashes that actually occurred that wasn't picked up by Navisworks. However, they weren't major, so that the project became halted, or that the timelines were affected, or that cost was affected, and instead it could have been resolved easily on site, allowing for the project to continue seamlessly without interruption. BUM 360 and ACC served as the primary cloud storage services. Autodesk Revit was used to model in architectural, mechanical, and structural design work. Civil work was done on Civil 3D, and all was brought together on Navisworks, where clash detection was done. The metal cladding. So what we attempted to do at the metal cladding, firstly, the metal cladding is something that's extremely resonant on the site, and it's something that a majority of the buildings in Duncanville and in the Vaal use as a means for an envelope as well as a roof. The cladding contractor was Centro Construction, and the cladding manufacturer was Cloten Steel. What we attempted to do was use a concealed fix design. The cladding system was used to design and complement the architectural language while also enhancing the building performance. So we used a concealed fixed standing seam system, and it was selected for its clean appearance, its durability, and also its long-term weather resistance. To further improve thermal performance, minimize thermal bridging, a continuous insulated layer of expanded polystyrene insulation boards were mounted both to the cladding walls and envelope walls, and also to the underside of the roof. The result is then a facade system and roof system that delivers an aesthetic quality, but also is energy efficient and reduce maintenance requirements over the lifespan of the building. Much of the facade and much of the roofing system was actually designed to be as lightweight as possible. Hence why the facade is actually just a EPS block, which is extremely light, in addition to the standing seam concealed fix sheets. And those two elements combined in thickness don't even make up 200 moles, excluding the substructure. What then did was reduce the load on the foundations, reduce the structural member size, column sizing, and overall reduce the amount of tonnage that would have been necessary for a building of this magnitude. The roofing and the gable roofs create this beautiful rhythm and repetition across the site, but what they also attempt to do is unify the entire development. So even though the development is designed as 5 units, what actually could happen is there could be an interchange where 5 units become 2 units, 2 units become 4 units, and the entire plate allows for this flexibility. And we thought we were actually quite proud of that, because in our initial client meetings, multiplicity and multivalency and the ability of spaces to transform and change was a big factor that the client required. And we believe as A4, the choice of using a portal frame system and sheeted roof was able to achieve what the client initially set out, but also do it in quite a beautiful manner. Fabrication. The steelwork contractor, Centro Construction. Our primary contractor was responsible for all of the fabrication that had occurred. And the fabrication process demanded a high level of precision due to the double
Guys, is everything okay? Everything just stopped. Are you there?
fabrication. The fabrication process demanded a high level of precision due to the double slope roof geometry and repetitive structural system. Tight tolerances were maintained throughout the fabrication process to ensure efficient assembly during erection. A combination of welded and bolted connections was used to maximize fabrication quality while simplifying on-site installation. The repetitive nature of the framing system improved manufacturing efficiency and contributed significantly to the project's successful delivery. The repetitive nature of the framing system also allowed fabrication efficiencies while maintaining strict dimensional tolerances. Close coordination between the engineering, detailing, and fabrication teams ensured that all components were produced accurately and integrated seamlessly during erection. Comprehensive quality control procedures were implemented throughout fabrication and erection, including material verification, dimensional inspections, connection checks, and final structural inspections. This rigorous approach contributed significantly to the accuracy and quality of the completed structure. So, the fabrication in general, we felt the steel system was the fabrication or the planning in the fabrication stage allowed for the building to be erected efficiently, safely, and with a high degree of accuracy as designed. Erection and installation. So the erection phase required careful planning due to the double slope roof geometry and the need to maintain the structural stability throughout construction. Steel deliveries, lifting operations, and installation sequencing were all coordinated to align with the construction program. The use of bolted steel connections simplified assembly and reduced site congestion. Continuous monitoring of alignment, geometry, and structural stability ensured that the completed structure met all design requirements. Next slide, please. Okay. So, okay. To close out, the erection phase required detailed planning, careful sequencing, and close coordination between all of the project stakeholders. Maintaining the stability, roof geometry throughout construction and installation was critical. A structured crane strategy, temporary bracing systems, and ongoing quality inspections ensured that the steel frame was erected both safely and accurately. The use of prefabricated and bolted steel components reduced site congestion and enabled efficient program delivery while maintaining high construction standards. Challenges and solutions. The project actually faced several significant challenges, including varying topography, dolomitic ground conditions, and areas of shallow hard rock. But rather than forcing the site to accommodate the building, the design was adapted to work with the natural conditions. The steel structure was stepped to follow the terrain, reducing earthworks and retaining wall requirements. When geotechnical investigations identified a restricted D4 dolomitic development zone, The flexibility of the steel framing system allowed portions of the building to be repositioned with minimal disruption to the overall design and program. And these challenges ultimately reinforce the value of steel as both a flexible and adaptable structural solution. Another significant challenge was the dolomitic rock, which was found beneath or below 1.5 meters of the natural ground level. But instead of looking at the dolomitic rock as some sort of constraint or restraint, what the team decided to do was to take the rock, employ a few skilled artisans and stonemasons, who then employed younger junior stonemasons. And we decided to clad portions of the building, specifically on the lower level, in the dolomitic rock that was actually excavated on the site, thereby linking the facade and the aesthetics to something that is truly rooted below the building's foundation. The primary issue, other than the topography, is actually the dolomitic zone. But our engineering team worked really hard and did a fantastic job to design the thinnest raft foundation alongside a geotechnical engineering mattress below that. And what that did was provide the necessary load-bearing capacity for us to efficiently construct both the warehouse structures, but also to add an additional load of precast hollow core slabs in the form of a mezzanine level per unit. The benefits of steel. So steel, up until now, I've just been rambling on the benefits of steel and how it linked back to every aspect of our design. But if we were to sum up what the benefits of steel actually were in this application, steel was fundamental to the success of the Vaal Lifestyle Center, in our opinion. It provided the long span flexibility, it reduced structural weight, it accelerated construction, and it also improved constructability. Its integration with the hollow core slab system enabled efficient floor construction, while its adaptability ensured that the development can respond to future tenant needs and also market demands. This project, we feel, demonstrates how steel can deliver architectural quality, structural efficiency, and long-term commercial value within a single material solution. Quality assurance, sustainability, and efficiency. Quality assurance was embedded throughout every stage of the project. Fabrication and erection activities were undertaken in accordance with the recognized industry standards and also with rigorous internal inspection procedures. Sustainability was supported through efficient material use, prefabrication, reduced construction waste, and the recyclability of steel. Together with low E glazing, solar energy generation, reused dolomite, and landscape interventions, these measures contribute to a development that performs efficiently while maintaining a strong architectural identity. However, sustainability is not just environmental. Sustainability could be political, it could be economical, it could be social, and it could even be cultural. And what we felt was, even though the initial brief didn't call for it, we wanted to add an anchor of socialism, or anchor of sort of, not an anchor, but more of a hub on the eastern edge of the site facing the primary vehicular thoroughfare. And what that did was, we assuming that if you provide a canteen or a restaurant, even if people are coming to work in the units as part of different enterprises, they then come together either before work, during the lunch hour, or even after work at this mini restaurant, and they socialize, they gather, they mingle, and that contributes to the social sustainability of the project. Economically, the Vaal has quite talented stonemasons and brick masons. However, when it comes to pouring concrete, I think contractors in the Vaal could learn quite a bit from people in the north. So what we attempted to do was create an in-situ wall solution where extremely skilled brick masons could learn another skill of developing walls, and that contributes positively to the economics of our contractors in the Vaal. Secondly, we only employed a few master stonemasons. Additionally to that, the stonemasons employed junior stonemasons, and they worked on the cladding of the project for a lengthy period of time. And we even recall on site that some of the stonemasons had said that this project had taught them how to actually carve and place stone. So therefore, we feel the project doesn't only tick the boxes of environmental sustainability, but it also attempts to create a new social hub in form of the restaurant and chill space, and it also attempts to contribute to the economics of the contractors located within the Vaal. What we're most proud of. So, I think in general, we're quite proud of putting together the building. We're quite proud of all of the challenges that we had occurred on site, because we were able to overcome it and produce something that at the end seamlessly integrated both architecture, structure, engineering, and terrible ground conditions into a project that we feel is quite rhythmic and beautiful. But the primary thing that I think we did well with was the steel. And the steel allowed us to create a development that is flexible, efficient, and architecturally distinctive. While the reuse of the site dolomite created a unique sense of place rooted in the Vaal region, most importantly, the project showcases that the power of collaboration between architects, engineers, contractors, and fabricators is essential. And the result is a development that not only meets the client's expectations, but also contributes positively to the community and the neighboring context of Duncanville. And with that, we bring our presentation to an end, and we thank you for your time and the opportunity to present this project. On behalf of A4 Consulting, Palms Properties, as well as Central Construction, this was a really fun and interesting project, and we hope we were able to take you guys through it in the simplest manner, and we hope you guys like it too. Thank you so much.